Welcome to Operations and Supply Chain University. I'm Jerry Wright. I'll be going through Introduction to Lean Six Sigma White Belt. We're now in section 2 of 5. What is Six Sigma? Six Sigma is focused on variation. Six Sigma aims to improve both quality and productivity through reducing process variation. Six Sigma utilizes data analysis techniques and statistical methods to analyze variation in a process, product, or service and determine ways to reduce that variation. Six Sigma is typically deployed through practitioners trained in Six Sigma DMAIC methodology. DMAIC means define, measure, analyze, improve, and control. So let's define Six Sigma. Six Sigma means the variation in a population is extremely small, so very little variation. A process at the Six Sigma level only has 3.4 defects out of 1 million units. In statistical terms, sigma, or you can see the sigma symbol there, is a letter of the Greek alphabet, and it represents the standard deviation of a population of items or data. Mathematically, it represents the variation from the average or the mean of the data. This is also known as the sigma level. So that's where the Six Sigma comes from. The formula for standard deviation or sigma is here. Don't worry about memorizing it. We have wonderful tools in Excel and other programs that calculate it for us very quickly. Now, there are 4 goals of a Six Sigma enterprise. It's important to know what these goals are. The first one is reduce defects. We want to have less variation in a very standard process. We want to improve yields. So we want higher yields, less waste, less scrap. We want to improve customer satisfaction. That's important. If we don't do that, customers will leave us. And then we want higher net income for the company. Now, where did Six Sigma originate? Now, I'm going to show you some company logos over here. Six Sigma was developed in the US electronics industry to reduce defects in electronic components. Back in 1984, Bob Galvin and Bill Smith, who both worked at Motorola, proposed the initiative of and created the first objectives of Six Sigma, with the goal of attaining a Six Sigma level of quality. Now, Texas Instruments and ABB worked closely with Motorola to further develop Six Sigma methodologies and capabilities in manufacturing. By 1992, Motorola had actually achieved Six Sigma capability in its electronics production quality. Again, that 3.4 defects out of 1 million units built. Pretty incredible. Now, 1995, so 3 years later, General Electric, who was then led by CEO Jack Welch, expanded the deployment of Six Sigma worldwide, capturing the interest of Wall Street, and sparking global interest. Now, deployment of Six Sigma today is worldwide, and it's a foundation of continuous improvement across many industries. Six Sigma at Motorola was initially just MAIC. They just looked at measure, analyze, improve, and control. Now, when GE got involved, they added define. Part of the reason they did that is they had so many projects to do. They wanted to better assess what projects should go forward and which ones should we wait on and do later. So the define was added by GE in 1995 timeframe. GE's extensive use and promotion of Six Sigma created a global boom of Six Sigma training in green belts, black belts, and master black belts throughout all industries worldwide. Now, today, Six Sigma is a proven continuous improvement methodology that is used globally. So how did Lean Six Sigma originate? Lean and Six Sigma were not combined until the mid-2010s. For nearly 20 years, they were two very passionate but very separate camps. The Six Sigma camp said Lean was not comprehensive enough and did not study the data and the process sufficiently to reduce variation. Conversely, the Lean camp said Six Sigma was too complicated and more difficult to learn, understand, and apply due to its statistical nature and focus on data. Now, by the mid-2010s, so 2014, 15, 16, professionals from both the Six Sigma camp and the Lean camp said, hey, why don't we just combine the two? We're being a little silly with saying, no, only Six Sigma, no, only Lean. They both have their values. Let's look at a synergistic approach by combining the two. And I was a big push for that throughout the industry. Not or, but and. How can we have Lean and Six Sigma? So let's look at the goals. We've covered the goals previously. Here's the Lean goals: improve quality, eliminate waste, reduce lead time, and then reduce total costs. Let's look at the Six Sigma goals. Reduce defects. Improve quality, right? Improve yields. Okay, that's also eliminating waste. Improve customer satisfaction with lead time or other things that are important. And then finally, higher net income, which would be, okay, reducing total costs. These are essentially equivalent. Now let's look at them as a combined session. So first, let's start with Lean. So here's the combined approach. We start with Lean. Lean is simpler, it's easier to understand, easier to use. We need to understand first what the customer defines is value and what's valuable. So we need to know what's valuable. Remember, the customer is not willing to pay for non-valuable things. So let's focus on reducing or eliminating waste or non-value added and make our process more efficient. We're going to focus on what's called a value stream. A value stream is essentially all the different things that a business must do to deliver products or services to its customer. And Lean is focused on value created across all the different functions or departments of an organization. In Lean, we're going to drive waste reduction, lead time reduction, setup reduction, anything we can do to make it more efficient and fast. Now, TPS, remember, Toyota Production System, and Kaizen are going to be used extensively. Kaizen is just a Japanese word for continuous improvement. Now, Six Sigma, we're going to reduce variation. We're going to take a total system approach. We're going to look at what's called SIPOC. SIPOC is a high-level process map that means suppliers, inputs, what do the suppliers provide us? What are the processes? What are the outputs? And then who do they go to? Typically the customers. So suppliers, inputs, process, outputs, and customers. We're going to follow that DMAIC methodology. Remember, define, measure, analyze, improve, and then control. We're going to work on reducing process variation. And keep in mind, in Six Sigma, we have a very good statistically focused toolbox to help reduce process standard deviation, or Sigma level. We're going to dig into things such as process capability, or CPK, and design of experiments, or DOE. Now, here's Lean Six Sigma. This is the combined approach. We first define value, then we remove waste, and with what's remaining, then we reduce variation in that order. We follow both Kaizen and DMAIC methodology simultaneously. We take a tiered approach. We start out with simple improvements, Kaizen, problem solving, 5S, and other simple things. Then we dig into the Lean tools. After that, we say, okay, now it's time to deploy the Six Sigma. We really need to reduce variation. So in this combined approach, we use the simplest tools first, then we progress to more advanced tools as we need to improve. Thank you, and I look forward to seeing you in another video series.